electrons. And so from carbon we have 2 by 4 plus 3 by 1 because of the hydrogen plus 5 because of the nitrogen. So 8 plus 3 plus 5, and that's going to give us 16 electrons that we need to figure out where to place. So let's just start with this general skeletal structure. And we can put single bonds between them if the hydrogen's around 1. And so we just start with that, okay? And so if, for whatever reason, we decided to fill in the octets like that, we'd see that it's over 16. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So let's start by getting rid of 4 of them. 2, 4, 6, 8. Yeah. And then let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18. So we're still going to be 2 over. So we can deal with this by getting rid of those 2 and having a double bond like that. Another bond like that. So 2, 4, 6, 8, 10, 12, 14, 16. Perfect. All of them are accounted for. We can check out the formal charges on all of them. Hydrogen has 1 valence electron, 1 electron in a bonding pair, so that's 0. Same thing for the other 2. Nitrogen has 5, 2 coming from here, 2, 4, 6 divided by 5 minus 2 minus 6 over 2. And that's going to give us 5 minus 5, and that's 0. Lastly, on the carbon, we have 1, 2, 3, 4, and again 1, 2, 3, 4. So no formal charges left over. That's going to be like this with a net charge of 0. Okay, next up, we would like the half reaction. So the cell diagram for the reaction occurring in silver zinc button batteries is like that. We'd like the half reaction that involves silver, the half reaction that involves zinc, at the balance for the net cell reaction and the cell potential, the standard potential of the cell. Okay, so if you know how to read cell diagrams, it should be read as such. So let's just write it out first. Okay, so if we could label it, the left-hand side of it represents oxidation. The right-hand side of it represents reduction. And what is in the middle is whether we're using an acid or base solution. So you can note it down when you're writing the half reactions, what you're providing the hydrogen ions with. And so in this case, of course, we'll be using a basic solution because KOH is a basic solution. So for the half reaction that involves silver, that's going to be reduction. And so we have Ag2O solid going to Ag solid. We can start out by balancing our oxygens. And so if we'd like to balance our oxygens, we know that we're balancing them with hydroxide ions. So plus OH minus. Next up, we'd like to balance our hydrogens. And so we see that we have one H here, but no H on the other side. And so we'd add H2O. And then we're going to multiply this by 2 because here we have 2 in the H2O. And so 2OH minus minuses and aqueous solution. Okay, so oxygen is fine, hydrogen is fine, but what's left is the charge. And so here we have a charge of 2 minus, here we have a charge of 0, so we're going to balance that out using electrons. So that it can become Ag2O solid plus H2O liquid plus 2 electrons to give us Ag solid plus 2 OH minus in aqueous solution. And that's going to be the half reaction that involves silver. Next up, we'd like the half reaction that involves zinc. That's going to be oxidation. So I'm getting these effects purely off of reading the cell diagram. And if you'd like confirmation that you're doing things correctly, just remember oil rig. So oxidation is the loss of electrons. So oxidation is loss, reduction is gain. So here we have reduction, and you see it's gaining electrons to become something else. And our oxidation half, we're going to want to see the loss of electrons. So we're going to want to see electrons on the other half of the equation. And so from our cell diagram, we know solid zinc is becoming solid zinc oxide. First up, we're going to want to balance oxygen. We're balancing oxygen with hydroxide ions because of the basic solution. So OH minus in aqueous solution becomes solid zinc oxide. Next up, we want to balance the hydrogens. Since we're going to add H2O to the other side to do that, we have 2 hydrogens, so we're going to want to multiply this by 2. So everything, all of the mass species are balanced, and next up we're going to balance charge. And so here we have 2 minus, we want 2 minus on the other side, and that can be done by adding 2 electrons. And so as expected, we're seeing electrons on the second half of the equation. And so for the net balanced equation, we don't need to multiply any of them by any common factors because the electrons lost equals the electrons gained, so that is okay. And so you just want to add these two. So let's just write it out here. And here. Okay, and so this is our reduction half and our oxidation half. And so when we add them, we would like to cancel